Hello, everyone. Is this working? Is this working? I can't really tell for some reason. Okay, great. So welcome to my talk. Thank you very much for coming along. You're all a bit far away. I feel like I should come a bit closer, but I don't think the cameraman would be too pleased with me. So my name's Adam, and I come from Switzerland. I was actually born and raised in the UK. I don't know if there are any football fans here, but Switzerland played Denmark earlier this week. And with 6 minutes to go, Switzerland was 3-0 up. And I was getting really excited because I'm going to come here and gloat about it. But you guys then scored 3 goals, and it finished 3-3 in 6 minutes. It was incredible, very frustrating for me, but well done. I guess there's probably a few Swedish people here as well. I know Sweden's just across the bridge there. I'm actually watching The Bridge right now, that TV series. It's really good. And a lot of people actually think that I am Swedish because they use Swiss and Swedish interchangeably as if they mean the same thing. Do you guys get that problem as well? Any Swedish people here? Yeah, so that is a thing. I work for a company called Particular Software, and we are the makers of a product called NServiceBus. Has anyone heard of NServiceBus here? That's quite a few of you. That's great. So if you're not familiar with NServiceBus, that doesn't matter. I'm going to show examples in NServiceBus just because it makes it easy. But even if you're not a .NET developer, don't worry either. If you don't know C#, don't worry. It's going to be fairly simple. But I think it'll at least give you an idea of some of the infrastructure that you may have to write if you're to implement some of the concepts I'm going to talk about. Now, I'm going to kind of mess with your minds a little bit and talk about a class of problems which not many people talk about, and it's to do with the runtime behavior of our code. Now, that's a strange thing to say because obviously we do think about the runtime behavior of our code. We don't just write random code. But there's a certain class of problems which only really become apparent when code is in production and running under scale and running with multiple users touching the same data. And I'm going to home in on this specific problem of time. So there is this thing called the arrow of time. Right? It was a term coined by a guy called Arthur Stanley Eddington. And it basically says that time runs in one direction, you can't look forward, you can only look back. And I'm not going to try and refute that, right? The arrow of time is a thing. I'm not going to try and bend physics. But I am going to kind of turn the way we look at time upside down and kind of invert it and give you a different view of it. Now, that may raise a few questions. I don't know if we'll have time for a Q&A in this session. I've got a lot of material to cover, but I'm around for the rest of the day, so tap me on the shoulder, throw your most difficult questions at me. Those are great conversations to have. Now, to give you some detail, to give you some background rather, I'm going to talk about multi-user systems, right? So this is actually the UBS trading floor in Connecticut and Stamford. I've actually worked on this trading floor. I spent about 2 weeks on this trading floor. And I've got to tell you, it was pretty loud. It was actually the biggest trading floor in the world at the time, and UBS were very proud of it. The thing is, with multi-user systems, with lots of people using these systems and touching each other's data, we can get consistency problems. Now, you might think, well, okay, if we're doing something like CQRS, anyone heard of CQRS here? Okay, that's almost all of you. So you know about things like event sourcing, eventual consistency, and that kind of stuff. But it turns out that even if you use kind of the old traditional kind of safe technologies like SQL Server or Oracle, and even if you write your system in a completely synchronous manner, consistency problems can still occur. Now, we tend to reach for things like optimistic concurrency. Anyone heard of optimistic concurrency? Yeah, that's quite a few of you. So you have this first one wins and last one wins thing. And we think, well, as long as we know that that's how it's working and the users know that's how it works, then we're going to be okay. But things can get a bit more complicated than that. So I'm going to take a slightly simpler domain, well, in terms of users anyway. So I want you to put yourself in the domain of online retail. So we're working for an e-commerce company, we're selling things online, and our business come to us with a new requirement. And they say, well, I was out playing golf today and I had this great idea. I said, if we give users who've spent a certain amount in a week a discount on their next order, we're going to get a better retention ratio, right? People are going to be more likely to come back and keep buying stuff on our website. So you think, okay, I'm going to do this properly. I'm going to use DDD, I'm going to use SOA, I'm going to use microservices, TDD, I'm going to tick all the boxes. Anyone read about DDD here? Like anything about Eric Evans and Vaughan Verne? That's most of you. So you know all about aggregate roots and entities and consistency boundaries and things like that. So you might write some code like this, and it's nice, clean code. You've got an order class, which you might call your aggregate root, and then you've got a submit method to submit the order. And in here, you look through all the orders for the same customer, right? You match the customer ID, and where the order is in the last week, right? So the order timestamp is greater than or equal to the current timestamp of the current order, less 7 days. You add up the total of the orders, and if it's greater or equal to 100, you give a discount of 10%, otherwise you give a 0 discount, right? So fairly straightforward. And as I said, you can unit test this, integration test it, all great, and it's nice, clean code. And it goes into production and it works. So what's so bad about this? What's wrong with this code? Well, first of all, I mean, you are putting a bit more pressure on the database, right? Because you're doing a historical lookup through the orders here. But you've read about techniques that are going to help with that. So maybe you just throw some more CPU at the box, or maybe you create some indexes, or maybe you create some eventually consistent views and things like that. And that tends to work okay, but it's more interesting when you think about what this customer actually means, right? We've got a customer ID here. Now, that's not necessarily just one user, right? This could be a corporate account. And you can do that with Amazon, right? You can create a corporate account and you can say, well, whenever someone orders something from Amazon, please use our corporate account so we get a discount. So what that means is potentially 2 users can come along at the same time and click the order button at the same time, right? So now you've got 2 threads talking to the database. Now, let's say our current weekly total is 90, right? And each of these orders is 10. Both of these threads are going to go to the database and see, our weekly total is 90. They're both going to give a 0 discount because that's not greater than or equal to 100. The problem is that the person looking after this corporate account who pays the bill is going to look at the bill at the end of the week or end of the month or wherever, and they're going to say, that's interesting. We actually sent in 11 orders in that week for $10 each. We should have got a discount on the 11th order, right? And they come to you and say, why didn't we get a discount? You said we'd get a discount. And you kind of look at this and you say, you kind of ordered too quickly. If you just waited a few seconds before that second order, you would have got the discount. You say, what do you mean waited a few seconds? How do you expect us to do that? And you say, well, I don't know. Let's say when someone's going to submit an order, they shout around the office and say, well, hang on, I'm going to submit an order. No one do anything. They submit the order, wait a few seconds. All right, all clear. You can order as well now. And the customer kind of look at you and say, are you mad? That's completely ridiculous. I'm off to Amazon. Bye-bye. And has anyone heard that term, death by Amazon? Right? This is what Amazon do. They kill firms which don't operate in the best way. And you think, okay, well, hang on a minute. I know how we can solve this. We've got this magic thing called transactions. Right? So, well, if we wrap each of these in a transaction, that's going to solve our problems for us. Yeah, but no. The problem is that all the major database platforms, so SQL Server, Oracle, Postgres, and all the rest of them, their default level of transaction isolation is to say that you can read stuff from tables in your transaction, and when you write back to the database, I'm not going to check that that stuff has changed in the meantime, right? So that means these 2 threads can go in, check those rows, they can write stuff to the database. As long as they're not writing the same row, the transactions will succeed. But the thing is that the problem is that level of isolation, it's a perfectly reasonable thing for the database to allow you to read data and for that data to change in the meantime while that transaction is happening. Now, there are ways around that, right? So you can have serializable transaction isolation levels, and there are things like nhibernate which allow you to switch stuff like that on, which will actually check to see if the rows that you read at the beginning of the transaction have changed in the meantime. The problem is, if you switch that stuff on, first of all, your performance goes to crap, right? So you can forget about Black Friday. You'll struggle to service a kind of regular Monday. And the second thing is that even if you manage to sort the performance out, you'll suddenly start getting loads of errors in the logs, right? You'll get transactions failing because of consistency problems, right? And because of clashes. Now, at that point, you kind of go, oh, crap, turn that back off again. But the thing is, when those errors are actually giving you a hell of a lot of feedback, they're actually telling you that there are consistency problems in your system. So we need to look for other ways to solve these things. And we've got things like another magic golden hammer, the batch job. Right? So we're going to get rid of this 2-threaded problem, And we're going to write a batch job which kicks in once a day on a single thread, and it's going to do something like this. It's going to loop through the customers. For each customer, it's going to look through the orders for that customer. And again, it's going to look for all the orders which were submitted in the last 7 days. It's going to sum them up. If it's greater than 100, I'm going to give that customer a discount level of 10. And if it's less, I'm going to give them a 0. Right? The consistency problem has gone. However, another problem has arisen. What's the problem with this? We're no longer penalizing people for clicking the button at the same time. We're penalizing them for clicking the button on the same day. Right? One user goes in, orders something in the morning, another user goes in the afternoon, orders something else. They don't get the discount on the second order because the batch job hasn't run yet. Right? It doesn't even have to be 2 users, it can be the same user. So you're effectively saying to the customer, if you want the discount, just wait until tomorrow. Right? Don't order too much stuff today. Order the rest of your stuff tomorrow and we'll give you a discount. Right? That's ridiculous. You've effectively taken a 2 or 3 second race condition and turned it into a 24-hour race condition. Right? I'm off to Amazon. Right? Death by Amazon. So that might have worked at some point in maybe the early days of e-commerce, kind of like a daily discounted method. But things don't tend to work that way now. Our businesses operate in a much more fluent and dynamic way. So that's a business problem. And now, even if you find a business scenario in the future where running something once a day does make sense, they tend to come with other problems. So if we look at how we actually write these things, as I said, we might have this nice kind of DDD, nice kind of tested code in the middle which encapsulates a database and is all nicely service-oriented and uses microservices and all the rest of it. But this kind of stuff tends to live on the outside of that, right? It tends to kind of, we didn't really design the domain to capture that in the first place, so now we've got to do this kind of historical lookup, and you kind of tack it on the side. And you might use the domain objects to actually talk to the data, or you might just go straight to the database because it's a lot more efficient, and you just throw entity framework at it or something, and you just talk to the database. Now, if you're lucky, you get to do this in C#, okay, or whatever language you're using for your domain. But whatever you do, don't let your DBA see it. Because if a DBA sees this, they'll say, that's that thing that's kicking in at 11 o'clock every night and slowing down our housekeeping processes. You've written it in C#? That's ridiculous. I can do this much better in SQL. Right? And the DBA rewrites your batch job in SQL. And I don't even know if this is correct SQL. I kind of copied a sample and just altered it a bit. Haven't done SQL for a long time, and not too sad about that. But the thing is, this thing then really does live kind of outside your domain, right? It's going straight to the data, and this is where you get problems where you make changes to your domain and you break batch jobs, and that kind of thing has happened to me a lot in the past. And the thing is that businesses have this annoying habit of coming up with new requirements. So they'll say, well, I was out jogging this morning, I had this great new idea, and that batch job thing you did a couple of weeks ago? Yeah, we need another one of those. Right? So all of a sudden another batch job appears, and this is just random SQL I just copied and pasted from somewhere. Doesn't really matter. It's all ugly, whatever it is. So, and then then they say, well, I was on holiday and I had this great idea by the pool, and then another batch job appears, and another batch job appears, and this has got adventure works in it. This is really random. So the problem is that this stuff starts to decline in significance. Right? It starts to kind of take a back seat, and it's kind of this stuff around the outside, this starts to become the application, right? I see some people smiling. I think you've seen this happen, right? I've seen this happen a lot, right? And I don't know if anyone's familiar with the strangler pattern. So there's a pattern whereby if you have a really ugly piece of code, you kind of put nice code around the edges, and you gradually take slices out of the old code until you kind of strangle it out of existence and it disappears. This is a kind of reverse strangler pattern. Right? It's nice code in the middle, and it's getting strangled out of existence by this stuff around the outside. And what sometimes happens is the DBA will sometimes write the initial version and then give it to you for maintenance. Right? This has happened to me as well. And I tell you what, this stuff starts to take over your life. It just grows and grows and grows. And I'm telling you this because I've been in this situation. I've lain awake at night thinking about how to debug a stored proc. And at some point, you think, when did I stop being a developer and become a DBA? You know, and to the point where I actually considered specializing in SQL Server at one point because it got so bad. I cherish the day that I made the decision not to. And you realize that what you've ended up here is this kind of like big ball of mud covered in stored procedures. You've got thousands of lines of stored procedures everywhere, and you've ended up in a horrible place. And I've got to tell you, it's a horrible place to be in. So what we need to do to avoid this happening is we need a new model of thinking about time. We need to rethink the arrow of time and put a new perspective on it. So here it is, right? Here's our arrow of time. And we've seen that as time progresses, we get orders coming into our website. When a given order arrives, right, let's just take this one here, what do? We look back through a week of history, we sum the totals up, and we find out how much that is in order to work out how much discount to give. Now, the thing is that users will often come to you and they will actually word the requirement in these terms. They'll say, right, I want you, when an order comes in, to look back through the history, take all the orders, sum up their totals. If it's greater or equal than 100, give the customer a 10% discount. You think, okay, well, that's exactly what I've done, right? I've been given this requirement and I've coded it. I've done exactly what's been asked of me. The thing is that I want to share kind of a revelation that I've had over the past couple of years, is that users don't actually give you requirements. What they do is they take their knowledge of the existing system, and within those constraints, they give you a solution as a workaround for the thing they're trying to achieve. So users don't give you requirements, they give you workarounds. Now, one of the challenges that we face as developers is to see past that. We need to see past the requirements to see what the actual requirements are. Now, the actual requirement here is not to look back through history and do a sum, blah, 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 blah. It's to, based on how many orders the customer's made this week, give them a discount, right? Now, that might seem like a subtle difference. It's just a kind of a wording difference, but it's important because when it's worded in that way, we don't immediately think, okay, we need to look back in time. Instead of looking backwards in time, we can look forwards in time, right? And no, I'm not going to kind of bend the arrow of time here. I'm not going to say you can foresee the future. But what you can do is you can kind of fold the future into your code right now. So let's take another look at the arrow of time. When an order comes in, what's the current weekly total? Right? It's 0. Okay, that's easy. So why not capture that in a variable? Call it the week total. And then based on that, we process the order. We give them a 0 discount because they've got no orders so far. And for the next order that comes in, we need to take this order into account. Okay, so we increment the week total by the order total. Now, here's the trick. We need to throw that information into the future 1 week to say that in 1 week, we need to decrement the week total by that amount, right? That kind of makes sense because that order total should be part of the week total for 1 week. So we know we need to do that in a week's time. And we actually do that, we actually decrement that total then. When the next order comes in, we do exactly the same thing. We add that order's total to the week total, and we throw a message into the future to say, in a week's time, decrement the week total by that order total. And they do exactly the same thing when the next message comes in. And so forth, and so forth, and so forth. Now, when a given order arrives, what do? Do we look back through the history? Well, we don't have to anymore, right? We just look at the week total. If it's more than 100, we give a discount. If it's not, we give no discount. So instead of kind of fudging the number, instead of taking these domain objects, which were originally designed for something else, and kind of looking back through their history and doing an aggregation and kind of fudging the number together, we folded the concept of a weekly total into the domain itself. Right? Instead of doing a lookup, we've kind of folded the history into our current state. And we've done it in a consistent way, because think about what we're doing. In our batch job, we are updating 1 row, right? We are updating the customer's discount level. Here, we're updating 1 row, okay? We're updating the week total for a customer, right? And databases are very good at guaranteeing transactionality around a single row, right? I'll come to that a bit more in a second. So it's a kind of upside down, inverted kind of anti-batch job. But the thing is, we need a good way to program this, right? We need a good way to program the arrow of time. And things like HTTP, really bad at this, right? I don't know a way of sending an HTTP request and having it arrive in a week's time, right? You can kind of, I guess you can kind of fudge it using a system.threading timer or something. That would work until your process crashes, right? Because you start your process up and you've forgotten that you need to do this thing. So we need another way to do this. So we can think about this kind of this arrow of time in the context of this customer as a kind of long-running process, right? A long-running process really is something that has multiple triggers, and holds some kind of state. So a standard process, a trigger comes in to do something, you do your work and you're done. Long-running process, you get one message, you do some work, you save some state, you get another message, you restore your state, do some work, save your state again, and at some point you might be finished, right? So in our example, that might be the customer might delete their account, right? And at that point, the customer's gone, you don't need to do discounting anymore, the process is finished. And the way we abstract that in NServiceBus is through something we call a saga. So a saga, the term saga in this context was coined in the late 80s, and it was a reaction to the problem of enormous transactions, typically in mainframes and things like that. It was soon realized that we need to break things down into smaller transactions to make them scale better. And the saga was designed as a pattern for, well, if transaction 1 succeeds, transaction 2 succeeds, but transaction 3 fails, we need to roll back the previous 2 transactions. So it's a kind of compensating pattern. The thing is that in the real world, things don't tend to really undo themselves, right? I often see when people talk about the saga pattern, they use this example of booking a holiday, and they say, okay, well, you book your flight, you book your hotel, and you go to book your car with, Hertz, and they're out of cars. So then you call the whole thing off, right? Holiday's off, we're not going, right? That's a ridiculous way to handle things, right? And if you see people using this example, please ask them not to, because it's a really poor example. You look for another hire car company. If they're full, you look for other ways of getting to a hotel, taxi, bus, or train. It really doesn't matter. But the point is, in the real world, business workflows are much richer than simply undoing things. So an NServiceBus saga is not really a kind of by-the-book saga, but saga is a fairly accurate representation of what we want to try and do. It's just that we allow richer workflows through it. So I'm going to show you a bit of code now, and let's see how we can use this to actually try and solve the problem that we're trying to look at right now. So I have a beard, and I like craft beer, but I'm going to get really hipster now and use VS Code for this, and I hope this is going to work. So I'm actually going to get rid of this and rewrite it, right? Because I want to show you how you actually write this stuff. So what I've got here is a couple of message classes, right? So we've got a submit order message with a customer ID and a total, and it's going to have some other stuff, but I'm not going to worry about that for now. And then we've got a process order message, and that has a discount on it, so 10% or 0%, and it will have some other stuff on it as well, which we don't worry about right now. Now, to create a saga to solve this problem, all we need to actually do is create a class, right? So I'm going to create a class called discounting. Let me just scroll that up. And this is going to be our saga class, but what we need some kind of type to store the data, right? We need to store some kind of state in this saga, because that's what this is fundamentally all about. So I'm going to create a nested class, right? I know some people hate nested classes, but I think it's actually quite a nice way to say that this class belongs to this saga and no one else should be interested, right? It is private data to the saga. So I'm going to call that discounting data. And what I do is I inherit from something called contain saga data. So you don't have to worry too much about that. All it actually does is give us an ID for the saga and the originator who sent the original message. You can use that for other stuff, but it's not relevant right now. And we need to actually create some properties to store our business data. So discounting is done per customer, right? We want to give discounts per customer. So I'm going to put in the customer ID. And we want to store our weekly total. Okay, so again, I'm just going to create a weekly total. I'm using a double. You probably want to use a money type or something with proper accuracy, but just for simplicity, I'm going to use a double. So week total. Okay. And now what I can say to the infrastructure is that, well, discounting is a saga, and its state is stored in a type called discounting.discounting data. And that gives us a method to oops, no, I don't want that. That gives us a method to implement, an abstract method, which is configure how to find saga. I'm going to come to that in a minute. The next thing we need to do is we need to tell the infrastructure what kind of message starts this saga. So what kind of messages are we interested in? And that is the submit order, right? So, So we actually need to say, I am started by messages of type submit order. And that gives us another method to implement, which is to actually handle that message. So the first thing we need to do here is we need to work out, for this order, how much discount do we give, right? So we can look at the week total and say, if the week total is larger than or equal to 100, give a discount of 10, otherwise give a discount of 0. Okay? Now we might have to do some other stuff in real life, but once we've fundamentally worked out a discount, we can actually process this order with that discount. So we can take this context object, which is also passed into the method, and we can say, send a process order message with a discount of the discount we've calculated. Okay, so we're not quite finished yet, because we need to take this order into account when the next submit order comes in, right? So we need to add to our week total the total of this order, right? Now, here comes the real trick. Now, we need to throw that information into the future. So say, in 1 week, we need to decrement the week total by this order total, right? Because it should only be part of that total for a week. So what we can do now is request a timeout, and we pass this context object into it again. And then we say something like time span from days 7, and we can just send the same message back to ourselves again, right? That's usually sufficient. Now, this is complaining because that has to be async, and now we get told that these have to be awaited. Okay, and now we're good. Now we actually need to handle that message in a week from now. Okay? So what we can say now is that I handle timeouts, also of type submit order. That gives us another method to implement. And we know now that when this method runs, 7 days has passed. Okay? This message will be delivered to us in 7 days. That's what the infrastructure does for us. So at that point, we know that we need to take away the week total. We need to take away, it's called state this time for one reason or another. We need to take away that total from the week total, and we need to do, of course, something like return task completed task. Who likes async await? Anyone like async await? Any fans? No, not really. I mean, the worst thing about it is, I think async await is great, but I hate what it does to my code, right? And NServiceBus 5 was actually completely synchronous. And we made NServiceBus 6 async, so we made the big transformation. And we kind of thought, well, do we really need to do this? And we've got a guy called Daniel Marbach who works for us, and he's a kind of async await expert. And he said, no, we really need to do that. We do need to do it. And he was right, because all the underlying APIs are async now, and we've actually seen enormous throughputs. I think if you compare NServiceBus 5 with NServiceBus 6, I think Azure Service Bus that had like a 30-fold increase in maximum throughput, and RabbitMQ had like a 7 or 8-fold increase in throughput. So the advantages are huge, but it's just a bit of a shame what it does to our code. And the last thing we need to do now is, remember that I said a saga, a discounting saga applies to a specific customer. So we need to tell the infrastructure that when a message of type submit order arrives, we want to map the customer ID of that message to the Saga's customer ID. And let me just drop that down a line. Okay, so this is basically telling the infrastructure, well, when you receive a submit order message, if you find a saga with that same customer ID, spin that up, restore the state, and operate on that. If you don't find one, create a new saga. Right? It basically tells the infrastructure how to write a where clause, effectively. Now, these are also some really good things to test. Right? So I've actually got some tests already written here somewhere, if I can find them. We've actually got we've got a package called NServiceBus testing, and I'm just going to go through this really quickly. But this gives you a testable message handler context. And what you can do then is you can take, say, 4 orders, one for 60, another for 60, another for 10, another for 20, and you can pass them through the saga and test if this thing works correctly. So they're really, really good TDD targets, if anyone here is a fan of TDD. And you can say, well, I'm going to pass the first order through, and I'm going to expect a discount of 0. Using this testable context, you can see what messages were sent from the saga. You can actually look at the sent messages. And all this long statement here is doing is taking out the last message, which is a process order message, and looking at its discount, and just asserting that that is 0. Second order, our week total should now be 60. So again, we should get a 0 discount. When the third order comes in, we've now got a total of 120, so we should get a 10% discount. Now here's the trick. We can pretend that a week has passed, right? And we can actually send order 1 into our discounting saga as a timeout, right? We're actually simulating time passing. And this is really, really good, and it's a really good thing to do, because you wouldn't want to kind of like integration test this, come in and click the button, wait a week and see if it works. That's quite a long-running test. So you can simulate that here by simply just invoking the timeout. And then you can handle the 4th order, and you should see that your discount's gone back to 0. And I'm going to really stick my neck out and actually try and run this in VS Code. If I've coded things correctly, it should pass. Yay, okay, right, so TDD for the win. Okay, so let's have a look at how this actually works in the background. As I said, the trick is up here in this, where is it? In this request timeout method, right? That's the trick. That's the thing that allowed us to do this. So how does that actually work in the background? So what we have is we have a bus abstraction, which basically abstracts over a message queue, and we have a persister abstraction, which abstracts over a database. And what we do is when a message arrives on the bus, we dispatch that into the saga. Saga will do its work, it will work on its state and save that down, and it will request a timeout. Now, at this point, the bus does one of 2 things. For some queuing systems, we can just say to the queuing system, send me that message back in a week's time. Right? They just support it natively. Other queuing systems, unfortunately, don't support it, so what we do is we persist that timeout in the database at the same time as we persist the saga, but then we have to poll that database to see when the timeout becomes due. And we'd rather not do that if we can avoid it. So we always favor the native queue mechanism when it's available. Now, currently, the only one which actually does that all for us is Azure Service Bus, right? So Azure Service Bus, despite its name, is just a queuing system, but it can actually do this native timeout thing for us. We can just say, give me this message back in a week. Other queuing systems kind of support it. So Amazon SQS, for instance, it does support it, but only up to 900 seconds. So you can send a timeout of up to 15 minutes with Amazon SQS. And that's fine if you say you want a 600-second timeout. You just say to them, give me it back in 600 seconds. But if you want a bigger timeout, like 2,800 seconds, for instance, things don't quite work so well, because you can only put it on the queue for 900 seconds. But what you can do is you can put a header on the message to say, well, when we get this back in 900 seconds, we've still got a remaining delay of 1,900 seconds, right? So we can put it back in the queue for another 900 seconds. And so, well, there's 1,000 seconds left now. We get that back, we put it back in the queue for 900. There's 100 left now. And then we can just put it into the queue for 100 seconds, right? So using that, we can actually simulate arbitrary delays in Amazon SQS. That's pretty straightforward. It gets more interesting with RabbitMQ. Now, RabbitMQ has this notion of time to live. So you can say for a specific queue in RabbitMQ, you can say messages that I send to this queue should stay there for this amount of time, right? And you don't subscribe to that queue. You put an exchange on the end of it, which is another Rabbit concept. And you say when messages die from this queue, they go to this exchange, and that exchange puts them in the actual queue, right? So you can do the same thing again. You can actually simulate delayed delivery in RabbitMQ using this trickery. And that works fine. So you create a queue for 600 seconds, you put your message there. Let's say you want a timeout of 900 seconds, where you create another queue with a time to live of 900 seconds, and so forth and so forth. So for each timeout, you just need to create another queue for that length of time. Now, you can see where that's going, right? The API looks like this. I can write any number I like in there, or I can write from days, or from months, or from years. I can put any kind of, or if I'm really evil, I can put math.rand in there, right? Just send arbitrary, random timeout. So it may not happen very often, but the problem here is the number of queues that NServiceBus might create for a system is potentially unbounded. And the last thing we want is a customer getting on the phone saying, why the hell is NServiceBus creating 10,000 queues in my Rabbit broker? So we need another way of doing it. So let's take an easier example, right? 42 seconds, a nice small number to make things easy. Now, the interesting thing about the number 42 is that not only is it the answer to the ultimate question, it is only the number 42 in a certain method of counting, right, which we know as decimal, right, or base 10. So in base 10, we want a 42-second delay. Now, we're software developers, and we know that there's other ways of writing numbers, right, and one of them is binary. So we know that we can write 42 in base 10 seconds as 101,010 base 2 seconds, right, or in binary. So what if, in RabbitMQ, we create a queue for 32 seconds, a queue for 16 seconds, a queue for 8 seconds, 4, 2, and 1, and so forth. We can take our 42 base 10 and write it in binary next to those queues, and using, again, some header trickery, we can write this value into the headers, this 101,010, and we can say, we can put an exchange in front of each queue and say, if there's a 1 in this position in the header, put it into your queue. If there's a 0, give it to the next exchange. And using that trickery, we can put it through that queue, not through that queue, through the 8-second queue, not the 4-second queue, through the 2-second queue, and not the 1-second queue. Now you can see it's fallen through 32 plus 8 plus 2, which is 42. So we can simulate arbitrary delays in RabbitMQ using this method. And we think that's pretty cool, right? I don't think anyone else has actually done this kind of thing, RabbitMQ. I think it's something we generally kind of invented ourselves, and it works really well. I'll tell you what, this translates into solving actual business problems, right? And there's nothing more satisfying than taking something like binary logic, right, binary numbering, fundamental computer science thing, and actually solving business problems with it. Right? So it's a really nice feeling. Now, we've only got 6 queues here, which gives us a maximum possible delay of 63 seconds, which isn't that useful, so we actually create 28 queues, right? And that gives us a maximum possible delay of 2 to the power of 28, or 268,435,456 seconds, or about 8.5 years. Now, you might think, well, where did 28 come from? That's a bit random and arbitrary. Well, most businesses don't tend to think about things in more than about a year, so we could have got away with 25 probably, which would have given you more than a year, but then we don't like odd numbers, so 26 was the candidate. And we thought, well, 26 we think is safe, but to be really safe, let's go an order of magnitude bigger. And we don't want 27, that's odd, so we went with 28. We were really tempted to go for 32, right? Because we like the number 32, but that would have given us a maximum delay of 136 years. So, I'd love to see people using NServiceBus in 136 years, but I think it's probably slightly overkill. If anyone really wants more than 8.5 years, we'll release a new version which will create a 29th queue. Yeah, whatever. So. We've seen that, we saw the consistency problem with this kind of original backwards lookup method. We replaced it with this nice shiny saga, but there's still potentially the same consistency problem here, right? because two people can still go in and click the button at the same time, and two sagas can look at the week total at the same time. So have we actually really solved any of our problems here? Well, as I said, we're touching a single row here, right? We're reading a single row and writing back to it. And databases are really, really good at guaranteeing transactionality around a single row. And we can take advantage of that. Now, the important thing is that when we actually send, let me just make this big again, when we actually send this message here, we don't actually send it at that moment, okay? NServiceBus will buffer it in the background, and only when the saga state is persisted would it then send the message. Okay, so bear that in mind. We can take advantage of all of this and say, when two threads come in at the same time, start the same saga type, they will look at the same weekly total, they'll both see 90, right? They'll both give a discount of 0, then they'll try and persist their saga data to the database, and they're in transactions because they're trying to write to the same row. One of them fails, right? And its message won't be sent because the state hasn't been persisted. That message then goes back to the queue, that gets dispatched into the saga again, and this time things work because that saga is now using the state that first thread persisted, right? So this second thread is now actually seeing 100 and it's giving the discount. So that's how we've solved that. Now, HTTP doesn't offer this, right? So if anyone here is not using a kind of message-driven architecture, something like that, when something fails, who retries? Anyone retry when something fails? Yeah, that's a few of you, or almost half of you. And that works fine if you're using something like HTTP, again, until your process dies, right? You start the process up again, your retry is gone. Unless you write it to disk, right? You can write it to disk, but whatever you do, I don't want anyone to go back and start writing HTTP requests to disk, right? And then polling them to see what's happened and to see what they need to send once to start the process again, because what you're doing then is basically writing a queue. Right? Don't write a queue, just use a queue. Okay? You'll be better off for it. So you think, okay, we're getting somewhere now. We've solved our consistency problems. We've got rid of our race conditions. Or have we really? And if you look at what we try and do when we actually ship the order, to get this thing out of the door to the customer, we might call a courier, so someone like DHL, and then we wait. And we wait. And we wait. And they don't turn up. Now, how long do we wait? How long should we wait for DHL to turn up? Well, you might say a day, right? A day is kind of reasonable, and the business might say, well, look, if DHL don't turn up in a day, call UPS instead, right? And now we can already see how we can use the mechanisms I've described to you to build this, right? We can send the message to DHL, send ourselves a timeout in 24 hours. If we hadn't received a message to say that DHL has shipped, at that time when we get the timeout in 24 hours, we call UPS. Problem is, what happens if, just as you're sending the message to UPS, DHL come along and pick up the package, right? And you think to yourself, oh, damn, we've got back to the same problem. I thought we got rid of race conditions. We've got a race condition again, right? And as developers, we often tie ourselves in knots trying to fix these things, right? And we do kind of crazy things like, well, we kind of reserve the transaction over here, and then we kind of get confirmation that they're going to do it, and then we say, okay, no, don't do it. But you can never actually eliminate the race condition, right? You can't actually have a distributed transaction between DHL and UPS, right? Try as hard as you like, you will not get that to work. But the thing is, this isn't actually a technical problem. This is a business problem. Because if you weren't using a computer to automate this, if you were doing this by, say, people manning phones and just calling people to get things done, this kind of thing could still happen. So because it's a business problem, you should speak to your business stakeholders about it. Describe this problem to them. And very often they might just say, no, that's not a problem. We'll sort that out. We'll get DHL to sign an SLA. All right? We'll get DHL to say, here's the deal. We'll use you as our preferred supplier if there's some kind of discount, but you must ship within 24 hours. If you don't ship in 24 hours, you must not ship at all. And if you do, if you turn up after 24 hours and take that package, that's on you. You've got to pay us for the cost of that product, or you've got to get it back, or whatever. Right? The race condition has actually disappeared because it never was a technical race condition in the first place. And the thing is that race conditions don't actually exist in business. Right? Or to put it better, race conditions don't exist in successful businesses, right? Successful businesses are the ones that remove race conditions, right? Did I mention death by Amazon? So you think, okay, well, now we've really got somewhere, so we don't really need batch jobs anymore, or do we? Well, there are some situations where you think, well, no, actually, we really do need a batch job for this. So does anyone work with systems which produce some kind of reports? Anything like that? Yeah, a few of you. So reports are interesting because the initial implementation, you might say, okay, well, just write this code to produce this report, and the user can just generate it whenever they want. And then you realize that, when they come in the morning and everyone runs these reports, the system performance just goes to crap, right? So you think, okay, well, this isn't really going to work for us. And then you speak to them and say, well, how do you actually use these reports? And they say, well, I just look at them in the morning, and I can decide what I have to do for the day. So you think, okay, right, I've got the solution to this. Batch job, right? Overnight batch job. As soon as people start going to bed in Copenhagen, we're going to switch on the batch job, we're going to create all those reports overnight, and that kind of works fine. But then as business grows, you can become a victim of your own success. Your customer base grows wildly, your order base grows wildly, and all of a sudden your batch job starts leaking into the morning, and then people are coming in, the batch job's still running, and then it starts to take until lunchtime. And I've seen this happen, right? I've actually seen this happen. But, we can throw more resources at that. We can buy more CPU, buy more RAM. We can get our DBAs on it and create more indexes and speed things up, and we can get things down to, finishing in time before people arrive in the morning. Then your company opens an office in Singapore, and all of a sudden the night becomes much shorter. Because when people are going to bed in Copenhagen, it's only a couple of hours before they're going to get up in Singapore, right? So your window is tightened even more. Then you open an office in New York and an office in San Francisco, and basically you have no night left, right? In the context of your company, there is no night in order to run your nightly batch job. But the thing about reports is, they look at these things in the morning every day, and they decide to do some things with them. But what's really interesting is when you look at how these reports are actually used, or what do you actually do with these reports? What is it you look for in these reports? And they might say, well, we're a bank, and we look for large transactions in high-risk countries, right? And if I see 3 of those within 5 days on a particular account, I kind of know that I really need to take some action. I temporarily lock the account, I inform the customer, this whole process kicks off, and I talk to my manager, and all the rest of it. And that's really interesting, because when you have those conversations, you start to get a ubiquitous language coming out. You find out there's such a thing as a large transaction. You find out there's such a thing as a higher-risk country. And you kind of model those things as business events. And you can create a saga which does some kind of level of automated pattern matching. So, again, using those mechanisms I've described already, you could listen to these events, and you could say, high-risk, large transaction, in high-risk country on this account, okay, and you add it to your collection. You send yourself a message into the future in 5 days' time to say, remove it from the collection, right? And then you can see again how you've got this sliding window, this sliding 5-day window of large transactions in high-risk countries. And if in that 5-day window you get 3 of them added to your collection, you need to do something. Right, you can actually go ahead and inform the user, send them an email. You can even go further than that. You can even go and lock the account automatically. You can even send an email to the customer. And you know what? When managers see this kind of thing, it's kind of mind-blowing, because they'll say, it's 4:30 in the afternoon, and you've just found a high-risk transaction. You usually look at that report at 9:30 in the morning, right? So what have you been doing all day? I say, well, no, this is one that's just happened. Well, what do you mean it's just happened? How can it possibly have just happened? Well, the system told me. That saga thing the developers were talking about a couple of weeks ago? Well, they deployed all of that, and now the system just tells me. It's kind of mind-blowing. And what, it actually told the customer already? What, and it actually locked the account already? It's like, oh my God, where do I sign up for more, right? That saga stuff, we want more of that. And the thing is that this actually translates to real business value. One of my managers actually looked a bit like this guy, funnily enough. Now, this actually translates to actual business value, right? We're talking about money here. And have I got this? These are Danish kroner, right? It's the right kroner. Yeah. It would be a bit embarrassing if it wasn't. But actually, no, money doesn't look like that here anymore, right? It looks like that. And that's how Danish money looks these days. I actually made a mistake. When I first came to Denmark, I took out some money at the airport in the ATM, and I've still got it, right, five years later. But you're actually adding genuine business value for your business here. This is actual, this is the kind of area where you can turn an IT department from a cost center to a profit center, right? You're actually adding genuine business value. And it's really rewarding. Now, I've only really kind of scratched the surface here, right? So if you want to go into this in a lot more detail, our CEO, a guy named Udi de Haan, who's the founder of NServiceBus, he runs a 5-day course on advanced distributed system design. I highly recommend that in person if possible, but it is available as videos. And I've put together a selection of those videos around long-running processes. So if you follow this rather long URL, I hope you can try not to get in the way, but take a picture of that, follow that URL, you'll get a free video package talking about this in more detail. I'll leave that up there for the next couple of slides. And I hope I've given you a different perspective of thinking about this certain class of problems, specifically about time, and another way to do things. And it often feels like something like a batch job is the only way out. But at Particular Software, one of our missions is to kill the batch job. Right? We actually released a blog post a couple of years ago called "Death to the Batch Job," so you can find that on our website. And it's something that we believe can be removed using these techniques, using this different perspective, and looking at the hour of time in the kind of reverse to how we normally look at it. So I hope that's been helpful. I guess I do have a little bit more time for questions. Anyone got any questions they want to throw at me right now before I wrap up? Yeah. Have I encountered any pitfalls or drawbacks with the saga pattern? That's a good question. So one of the things that users often get themselves into is this trap of trying to query the saga data. Okay, so we get a lot of requests saying, how do I actually query the saga data? Because I want to know about the status of the process. I want to know where we are in this process, what the customer's current total is, and how many customers have we got with different levels of discounting and all the rest of it. And we often find that people actually go and implement that, and they start actually reading the saga data. The problem with that is, the reason that sagas are such good test targets, I describe them in TDD terms, is that they're very, very strong encapsulations, right? It is, has anyone read anything by Alan Kay, who kind of wrote the initial stuff about object orientation? And he didn't really talk about things like polymorphism and inheritance. He talked about messages coming in, private data, and messages coming out, right? So that's really what an object was. It encapsulated private data and operations on that data. Now, I often say that sagas are kind of object orientation done right, okay? And it's because there's such strong encapsulations. Now, the pitfall there is that when you start going behind the sagas back and going into the database, you break that encapsulation. So it's a very common problem I've seen. Now, the thing is that you can get around this in other ways. You can raise events from your saga, and then you can denormalize them into views, right? Kind of like in almost CQRS's fashion, right? You can do that, but we get this requirement so many times. We get customers asking for this so many times. How do I query the saga data? That we're looking into some way to actually provide that as a first-class part of the infrastructure. But until that exists, until we've thought about how best to achieve that, that's one very common pitfall I've seen, is that people break the encapsulation and all of a sudden they're in this bind where they can't change anything anymore, because it's almost like you've got batch jobs looking in from the outside because you're breaking past the encapsulation. Does that more or less answer your question? Yeah. Okay, so I'm going to wrap up there. I hope you've enjoyed that. I hope that's going to be useful. I hope that gives you a nice different perspective and a nice different way to think about these classes of problems. I've really enjoyed talking to you, and I'll be around for the rest of the day, as I say, if you want to ask me some more nice, tough questions. And enjoy the rest of the day, and thank you very much.